Every planet you have ever seen in a diagram spins more or less upright. They lean a little. Earth tilts by about 23 degrees, and that gentle lean gives us our seasons. But they all turn like spinning tops, their poles pointing up and down as they circle the sun. All of them but one. Far out in the cold, the seventh planet does something no other world in the solar system does. Uranus lies on its side. Its axis is tipped by about 98 degrees, which means the planet does not spin like a top at all. It rolls around the sun like a ball, one pole aimed almost straight at the sunlight for decades at a time, while the other is buried in a darkness that lasts the better part of a human lifetime. And here is the first strange thing about Uranus. When you look at it, none of that violence shows. You see a pale blue-green sphere, smooth and quiet, almost featureless. A world so calm to the eye that it seems like the most boring planet in the Sun's family. That calm is a disguise, because almost nothing about Uranus is actually simple. Something had to tip a giant planet onto its side, and whatever did it was not gentle. Beneath that placid surface sits an interior we still cannot describe with confidence. A magnetic field that points the wrong way, and a strange, missing warmth that no one has fully explained. Uranus is not the dull one. It may be one of the most violently rearranged worlds in the entire solar system. And there is one more problem. The problem that hangs over everything we are about to say. We have only ever visited Uranus once. A single spacecraft flew past it for a few days nearly 40 years ago, and it now looks as though that one glimpse may have caught the planet on the strangest day of its life. This is the story of a world tipped on its side by something ancient and enormous, and of how little we truly know about the wound. To understand what happened to Uranus, you first have to understand what Uranus is, because it does not fit neatly into the categories we like to use. We tend to sort the outer planets into gas giants, Jupiter and Saturn, enormous balls of hydrogen and helium, and then quietly assume Uranus and Neptune are just smaller versions of the same thing. They are not. Uranus belongs to a different kind of world entirely, one we call an ice giant, and that name is far softer than the reality. In planetary science, the word ice does not mean frozen water the way a glacier is frozen water. It means the volatile compounds that were solid in the cold outer reaches of the young sun's disk: water, ammonia, methane, and related materials. Uranus is built with a far larger share of these heavy, volatile-rich substances than Jupiter or Saturn. It still has an envelope of hydrogen and helium wrapped around it, and it is genuinely massive, more than 14 times the mass of the Earth. But most of that mass lies deeper down, in dense material, not in the light gases that dominate the true giants. And that raises the first real question about how Uranus came to be. Because a planet that big, forming in that part of the disk, should have had every opportunity to become another Jupiter. Out beyond the frost line, where water could freeze into solid ice, there was more raw material to build with, and planetary cores could grow quickly. Once a growing core crosses a certain threshold, it begins to pull in hydrogen and helium from the surrounding disk, and that process can run away. The planet swells, the gas floods in, and a giant is born. Jupiter did exactly that. Saturn did a version of it. Uranus did not. Neither did Neptune. So the mystery is not only how Uranus formed, but why it stopped. Why it grew large enough to become a true giant world, gathered more than a dozen Earths worth of material, and then failed to take the final step into becoming a gas giant. Perhaps the disk of gas around the young sun was already thinning and vanishing just as Uranus reached the threshold. Perhaps its core came together too late. Perhaps, so far from the sun, the whole process simply ran more slowly in a race against a disappearing supply of gas. There is no single clean answer, and that uncertainty is not a flaw in the story. It is the atmosphere of the outer solar system, a place that is harder to build planets in and yet richer in the raw ingredients than anywhere closer to the sun. What Uranus preserves, because of this, is a record of that outer region. Its bulk composition, its density, the very fact that it is starved of hydrogen and helium compared to Jupiter, all point to a world rich in heavier materials. And that makes it a kind of frozen witness to how planets assemble far from their star. This matters well beyond our own solar system. When astronomers survey the planets around other stars, worlds in the mass range of Uranus and Neptune turn out to be among the most common large planets in the galaxy. And yet, in our own back garden, the ice giant is the one class of planet we have explored the least. That sideways spin also does something to Uranus that happens nowhere else in the solar system. Because the planet is tipped almost fully onto its side, its seasons are the most extreme of any world we know. As Uranus makes its slow, 84-year journey around the sun, each pole is angled to face the sunlight for roughly 42 years at a stretch, bathed in a long, continuous day, and then swings away into an unbroken night that also lasts around 42 years. Imagine a winter that stretches for 4 decades, and a summer just as long. The atmosphere, the clouds, the flow of heat and weather all have to respond to a rhythm of light and darkness that no other planet ever experiences. Whatever tipped Uranus over did not just change which way it points, it rewrote the very meaning of a year. And for all its reputation as the dull one, Uranus is not the lifeless, painted ball it can appear to be. Its soft blue-green colour comes from methane high in its atmosphere, which absorbs the red part of sunlight and reflects back the cooler tones. But that placid face hides a genuinely active world. When Voyager 2 flew past, Uranus looked almost blank and featureless. Yet in the years since, sharper eyes have told a different story. The Hubble Space Telescope, and more recently the James Webb Space Telescope, have watched the planet shift and stir, brightening polar caps, changing bands of haze, and seasonal weather waking across a globe governed by that impossible tilt. It is not a dead sphere painted a single colour. It is a living atmosphere, running under some of the most extreme conditions anywhere among the planets. That neglect becomes almost painful when you look inside Uranus, because the interior refuses to behave. For a long time, people pictured a simple, tidy structure: a rocky core, an icy mantle, and a gaseous envelope, stacked in neat layers, like a diagram in a textbook. That picture was useful as a first guess, but useful is not the same as true. More recent modelling has made Uranus less comfortable, not more. The interior may not have clean boundaries at all. Instead of tidy layers, there may be gradual transitions, regions where the material blends from one form into another. There may be deep zones where water, ammonia, and methane-derived compounds exist under such crushing pressure that they take on exotic states. Not familiar liquid, rock, or ice, but hot, compressed, electrically active matter of a kind our intuition is badly unequipped to imagine. This is where Uranus stops being merely a planet and becomes almost philosophical. A world can be real, measured, and relatively nearby, and still hide its most important workings inside forms of matter we can barely describe. And those hidden depths may hold the key to what happened to it. Because the single most famous fact about Uranus is that it is tipped over. Its rotational axis lies at about 98 degrees relative to where you would expect it to sit. In plain terms, it spins almost exactly on its side. As it moves along its 84-year journey around the Sun, one pole can face the sunlight for decades, while the opposite half of the planet is left in a long, unbroken darkness. This is not a gentle lean like Earth's. This is planetary reorientation on a colossal scale. And so the obvious question becomes impossible to avoid. Something happened to Uranus. What? The leading explanation, and it is worth being careful to call it the leading explanation rather than a proven fact, is that Uranus suffered one or more giant impacts during the last stages of its formation. A collision with a large enough body, striking at the right angle, could have tilted an entire planet over. This is not wild speculation pulled from nowhere. Giant impacts are already central to how we explain other events in the solar system. Most famously, the likely birth of our own moon, blasted into existence when a Mars-sized world struck the young Earth. In the era when planets were still assembling, worlds did collide, and not metaphorically. They were built through a violent sequence of impact, shattering, merging, and reassembly. If Uranus was struck by a protoplanet massive enough to shift its spin, the consequences could have reached far beyond a simple tilt. Such an impact could have poured enormous energy into the outer layers of the planet. It could have stirred and mixed some regions while leaving others strangely stratified. It could have reshaped the material that would go on to form its moons and rings. It might even help explain why Uranus today gives off so little internal heat compared to its near twin, Neptune. In other words, the impact idea is not just about which way the planet points. It is about the entire character of the world. A planet that may be not merely tilted, but thermally and structurally wounded. But even here, the story refuses to become simple. And this is where an honest account parts ways with a dramatic one. Under some models, a single impact is not enough to explain everything, and researchers have proposed multiple collisions instead. Others have suggested slower, gentler mechanisms, long, patient gravitational tugs that tilted the planet over great spans of time without a single catastrophic blow. There are questions about whether a collision violent enough to knock Uranus sideways should have left its family of moons arranged the way we actually find them. So even the most cinematic version of Uranus's origin, the sideways world born from one colossal strike, remains genuinely scientific rather than mythic. It explains a great deal. It does not explain everything. And that restraint matters, because Uranus is strongest as a subject precisely when we do not pretend to know more than we do. The planet's own family only deepens the puzzle. Uranus has 5 major moons: Miranda, Ariel, Umbriel, Titania, and Oberon, and they orbit in the plane of the planet's equator, which is itself tipped over along with everything else. That single fact ties the moons tightly to whatever event tilted the planet. Either they formed after the tilt, from a disk of debris already lying in the new sideways plane, or an older system was somehow dragged into alignment over enormous spans of time. If a giant impact threw a ring of shattered material around Uranus, then the moons we see today may in some sense be the children of that same catastrophe, not merely companions to the planet, but pieces of the damage itself. And one of those moons hints at just how violent that history may have been. Miranda, the smallest of the 5, has a surface that looks like a world broken apart and clumsily put back together. It is scarred by enormous cliffs, fractured terrains, and strange, mismatched provinces that seem to belong to different worlds stitched into one. Not all of that must trace directly back to the tilting of Uranus. But in this system, nothing sits in isolation. These moons orbit a planet with a radical sideways spin and a likely violent past. And their broken geology feels like part of the same long story of impact and aftermath. Then there are the rings. Uranus does have them, though they are nothing like Saturn's bright, sweeping spectacle. They are dark and narrow, harsh and skeletal, like the remnants of a system that never quite decided whether to become elegant or broken. Rings are not just decoration. They are laboratories of collision and confinement, of debris being ground down and shepherded by the gravity of nearby moons. Some of Uranus's rings may be surprisingly young. They may be replenished or record disruptions we have not witnessed. Around Uranus, even the beauty feels provisional, as though the whole system is still recovering from something. And all of this circles a planet with one of the strangest magnetic fields we have ever measured. On most worlds, a magnetic field lines up roughly with the planet's spin and sits centered in its core, like a bar magnet running down the middle. Uranus refuses that simplicity. Its magnetic field is both strongly tilted away from its rotation axis and shoved off-center, displaced from the middle of the planet entirely, as though the machinery generating it is not where it ought to be. The engine of that field, the churning, electrically conducting region deep inside, does not seem to be operating in a deep, symmetric, comfortable core. It may be running in some shallower, lopsided shell, in an interior that is anything but ordinary. And a magnetic field is not painted on afterwards. It emerges from the arrangement of matter, heat, and motion deep inside. So the strangeness of the field is one more witness pointing to the same conclusion, that the inside of Uranus is profoundly unusual and inseparable from whatever shaped its birth. But of all the anomalies, the one that unsettles me most is the missing heat. Jupiter and Saturn both radiate more energy into space than they receive from the Sun, leftover warmth from their formation, still leaking out billions of years later. Even Neptune, Uranus's near twin, glows with a substantial internal heat of its own. Uranus, by contrast, gives off almost none. It appears, at first glance, to be a planet that has somehow gone thermally cold, shut down, subdued, reluctant. And that should not be possible. A world this large should be holding an enormous reserve of primordial heat, generated as it formed, compressed, and settled. So where did Uranus's heat go? One quiet, unsettling possibility is that it did not go anywhere. It may still be there, simply trapped. If the interior is stratified into layers that resist mixing, then the great churning motions that normally carry heat up to the surface can be suppressed. The warmth leaks out slowly or barely at all. The deep interior holds its energy, but never advertises it. Under that view, Uranus is not cold in the ordinary sense, it is bottlenecked. And a violent event long ago, a giant impact depositing energy in just the wrong way, could have helped set up that very structure. Which leads to one of the eeriest ideas in all of planetary science. A collision that happened billions of years ago may still be controlling how Uranus breathes today. So the mystery tightens into a single wall of strangeness. The sideways spin, the weak missing heat, the lopsided magnetic field, the uncertain exotic interior, the broken moons and the dark skeletal rings. No single one of these proves a grand catastrophe on its own, but taken together, they stop making Uranus look like a calm, ordinary member of a category, and start making it look like a giant planet whose whole history swerved violently away from the clean, tidy path we expected. And now we arrive at the twist, the fact that quietly undermines almost everything I have just told you. Because nearly all of our detailed knowledge of Uranus comes from a single encounter. One spacecraft, Voyager 2, flew past the planet in 1986. It gathered its data across just 5 days, revealed 10 new moons and a set of rings, changed planetary science forever, and then it was gone, carried onward into the outer dark. Everything since has been inference, layered carefully on top of that one brief visit. We have been reconstructing an entire world from a single glimpse. And in 2024, researchers went back to Voyager 2's old measurements and found something that should give us pause. It appears the spacecraft arrived at Uranus during a rare burst of solar wind, an intense stream of charged particles from the Sun that slammed into the planet just days before the flyby and dramatically squashed its magnetic bubble. According to that analysis, the spacecraft caught Uranus in conditions that occur only about 4% of the time. The lead scientist put it bluntly, "We just caught it at a freak moment." If Voyager 2 had arrived only a few days earlier, it would very likely have seen a completely different, far more ordinary magnetosphere, one much more like the fields around the other giant planets. Think about what that means. Some of the very strangeness we have spent 40 years trying to explain, the peculiar, seemingly empty magnetic environment, the unusually intense belts of radiation, may not be permanent features of Uranus at all. They may partly be the signature of one bad day, captured by a single passing probe and then treated for decades as the normal face of the planet. A follow-up study in 2025 has continued to re-examine those radiation belts in the same light. As one physicist involved admitted, we do not really know very much about Uranus, precisely because it was only ever a single flyby. We built much of a planet's identity from one pass through a storm. And here the story turns from unease towards something like hope, because that same humbling discovery is quietly good news. If the strangely empty magnetic bubble the Voyager 2 measured was really the result of a passing solar storm pushing material out, then Uranus's magnetosphere may normally be far busier than we assumed. And that reopens a wonderful possibility. Some of Uranus's major moons, worlds like Titania and Oberon, might be more active than we ever gave them credit for. There may even be liquid water hidden beneath their frozen surfaces. For years, the Flyby's data had encouraged us to write these moons off as inert and dead. The new reading suggests they might be quietly alive, and that we simply saw them, like the planet itself, on the wrong day. It also reframes the difference between Uranus and Neptune. These two ice giants ought to be siblings, similar in size, similar in broad composition, formed in the same distant, chilly reaches of the disk. And yet Neptune radiates its inner heat, while Uranus does not. And Neptune stands upright, while Uranus lies on its side. Perhaps they began from broadly similar ingredients and then diverged, pushed apart by later events. A giant impact here, a different history of migration there. In that case, Uranus is not a fundamentally different kind of world from Neptune. It is a similar world that was struck harder or reshaped more violently, and then left to carry the consequences alone. It would be, quite literally, a planet defined not only by its birth, but by its trauma. That is why scientists now speak so seriously about going back. Uranus has climbed to the very top of the list of places a future flagship mission should visit. Not because it is beautiful in the conventional sense, but because it sits at the crossing point of too many unanswered questions. How do ice giants actually form? Why do some giant planets stop short of becoming another Jupiter? How is a violent impact recorded in a planet's interior billions of years later? What we need is not one more distant photograph. We need a spacecraft that settles into orbit and stays, that measures the planet's gravity to map the mass hidden inside it, that drops a probe into the atmosphere to taste its composition directly, that watches the magnetic field across years rather than days, so that no single storm can ever again be mistaken for the whole truth. Because in the end, that is what makes Uranus so haunting. It is not just far away, it is unresolved. A pale, quiet world, tipped onto its side, radiating almost nothing, wrapped in a magnetic field that seems to come from the wrong place, encircled by dark, narrow rings and broken moons that may themselves be the wreckage of some ancient blow. It looks, at first glance, like the most minimal planet in the Sun's family. But the longer you sit with it, the more it begins to feel like one of the most violent. Not because it is exploding now, but because so much of its present stillness may be the frozen residue of a long-ago disaster. To say that Uranus formed is true, but it is not enough. Uranus was assembled and interrupted and very possibly struck. It was reoriented, perhaps remade in part, thermally altered, dynamically entangled with its neighbours, and then left out in the outer darkness to keep the evidence in silence for 4.5 billion years. That may be the most honest way to describe it. Not simply the seventh planet, not merely the one that lies on its side, but a giant world that may still be holding the posture of the blow that changed it. And that is what lifts Uranus above being a mere curiosity. It is a reminder that the making of planets is not always a clean and orderly thing. Sometimes a world is not just built. Sometimes it is wounded and survives and carries that wound quietly across billions of years until a small, curious species on a warm blue world finally looks out into the cold, notices the strange tilted planet rolling through the dark, and begins, at last, to ask what happened to it.